Hello everyone. Today we are going to analyze this beam using three moments method. Before analyzing, let's see the beam one time. In this beam there are three spans: span AB, span BC and span CD. In the span AB there is a concentrated moment 25 kN meter acting at 2 meter from the point A. In the span BC, there is a concentrated moment 20 kN meter acting in the center. Both of the moments are acting in the clockwise direction. In the span CD, there is a concentrated load 12.5 kN acting at 3 meter from the point C. In the points A, B and C, there are hinged supports. In the point D, there is a fixed support. Span AB is 5 meter long. Span BC is 4 meter long. Span CD is 5 meter long. In this beam, we have to find three moments. In the point A, there will be no moment because it is the simply supported end. In the point B, we have to find MB. In the point C, we have to find MC. In the point D, we have to find MD. So, the number of moments to be found is 3. Using two spans, we can make one equation. Using the spans AB and BC, we can make one equation. And using the spans BC and CD, we can make one equation. So, in this way, we can make two equations, but the number of equations required are 3. So, we have to make an imaginary span on the right of D. You can see that I have made an imaginary span D0 on the right of D, having the length L4. Now, using this beam, we can make three equations. First, let us take the span AB and BC and make the first equation. Before applying the theorem of three moments, let us calculate the ordinates. To calculate the ordinates, we have to assume every span as a separate simply supported beam. In the span AB, there is a concentrated moment 25 kN meter. It is not acting on the center. The formulas to calculate the ordinates are MB upon L and MA upon L. Here M is 25, A is 2, B is 3. When we apply the values inside the formula, we are getting 15 and 10. On the right side, it will be positive, and on the left side, it will be negative. Now, let us take the span BC. Here, there is a concentrated moment acting on the center. The formula to calculate the ordinates are m upon 2 and m upon 2. Using the formula, we are getting 10 and 10. On the right side, it will be positive, and on the left side, it will be negative. Now, let us apply the theorem of three moments in spans AB and BC. In this equation, let us calculate 6A1 x bar left upon L1 and 6A2 x bar right upon L2. For the span AB, we have already calculated the ordinates 15 and 10. In this formula, let us apply the value of L1. L1 is equal to 5 meter. Then let us calculate area 1 x bar left. Here there are two triangles. One is below the line and one is above the line. In this kind of right angle triangles, the centroid distance towards this point is 2b upon 3 and towards the right is b upon 3. The area formula is half into breadth into height. First, let us take this triangle. Since it is below the line, we have to mark it negative. We know the area formula of the triangle, half into breadth into height. Here the breadth is 2 meter, height is 10. Using that we will get the area. For this triangle, the centroid distance towards the left is 2 upon 3 into breadth. 2 into 2, we will get 4. So the centroid towards the left is 4 upon 3. Now let us take this triangle. First let us calculate the area. Then we have to calculate the centroid. For this triangle, the centroid distance towards the left is 1 upon 3 into breadth. Here the breadth is 3. Let us apply that. But we need the centroid distance up to the point A. So we have to add this distance. This distance is 2. So totally the centroid distance is 2 plus 1 upon 3 into 3. We can eliminate this 3 and 3. Finally we will get 3. After the calculations we are getting 65. Now let us take the span BC and calculate 6a2 x bar right upon L2. Length of BC is 4 meter. So for L2 let us apply 4. Now let us calculate a2 x bar right. Here also there are two triangles, but both of them having the same dimensions. In this case, let us keep the area outside because it is same for both of the triangles. Then we have to find the centroid. For this triangle, the centroid is 1 upon 3 into breadth. But we are calculating the centroid distance up to the point C. So we have to add this 2 meter. So for the centroid, we will get 8 upon 3. Since it is negative, we have to apply the centroid as negative. Then let us calculate the centroid for this triangle. The formula to calculate the centroid is 2 upon 3 into breadth. Using that we are getting 4 upon 3. After the calculations we are getting minus 20. In this equation let us apply the values. L1 is 5, L2 is 4. Let us apply them also. We know that in the point A there will be no moment. So MA is equal to 0. MA into L1 we will get 0. Finally we are making the first equation. Now let us take the spans BC and CD and make the second equation. For BC, we have already calculated the ordinates. Now let us calculate the ordinates in the span CD. Here there is a point load 12.5 kN. It is not acting on the center. The formula to calculate the ordinate is WAB upon L. Here W is 12.5, A is 3, B is 2. After applying the values inside the formula, we are getting 15. Now let us apply the theorem of three moments in spans BC and CD. Here we have to calculate 6a2 x bar left upon L2 and 6a3 x bar right upon L3. Let us take the span BC and calculate 6a2 x bar left upon L2. L2 is equal to 4. Let us apply that. We know that these both the triangles are having the same dimensions. So the area will be same. For this triangle, the centroid towards the left is 2 upon 3 into breadth. Here the breadth is 2. Let us apply that. 2 into 2, we will get to 4. So the centroid distance towards the left is 4 upon 3. Since it is negative, we have to apply the value in negative sign. Now let us take this triangle. The centroid distance towards the left is 1 upon 3 into breadth. Here the breadth is 2 meter. Let us apply that. Here we need the centroid distance up to the point B. This distance is 2 meter, so we have to add it. Finally, the centroid distance we are getting is 8 upon 3. After the calculations for 6A2 x bar left upon L2, we are getting 20. In the span CD, we have to calculate 6A3 x bar right upon L3. Length of CD is 5 meter. Let us apply that. The area formula for this triangle is half into breadth into height. Using that, let us make the area. Then we have to find x bar right. In this kind of triangle, the centroid distance towards the right is L plus B upon 3. Here L is 5 meter, B is 2 meter. Let us apply the values in the formula. So for the centroid distance towards the right, we are getting 7 upon 3. Finally, after the calculations, we are getting 105. In this equation, let us apply the values which we calculated just before. Also, let us apply L2 and L3. After the calculations, we are making the second equation. Now, let us take the spans CD and the imaginary span DD0 and make the third equation. Let us apply the theorem of three moments in spans CD and DD0. Here this term will be 0 because this is for the imaginary span. So we have to find only 6A3 x bar left upon L3. In the span CD, we have to calculate 6A3 x bar left upon L3. We know how to calculate the area. Now we have to calculate x bar left. For this kind of triangle, the centroid distance towards the left is L plus A upon 3. Here L is 5, A is 3. Let us apply the values inside the formula. So for the centroid towards the left, we are getting 8 upon 3. After the calculations, we are getting 120. Now in this equation, let us apply the values. This term and this term will be 0 because they are for the imaginary span. L3 is equal to 5, L4 is equal to 0. Let us apply the values. After the calculation, we are making the third equation. Alternatively, using the formulas, we can calculate 6A x bar left upon L and 6A x bar right upon L. Using the formula, let us make the first equation. In the span AB, there is a concentrated moment. Here we have to calculate 6A x bar left upon L. The formula is minus m upon L into 3A square minus L square. Let us apply the values inside the formula. M is 25, A is 2, B is 3, L is 5. After applying the values inside the formula, we are getting 65. Now, let us take the span BC. In the span BC also, there is a concentrated movement. Here, we have to calculate 6A x bar right upon L. The formula is m upon L into 3b square minus L square. Here m is 20, b is 2, L is 4. When we apply the values inside the formula, we are getting minus 20. Using these two values, we can make the first equation. Now let us apply the formulas in the spans BC and CD and make the second equation. In the span BC, we have to calculate 6a x bar left upon L. The formula is minus m upon L into 3a square minus L square. Here m is 20, a is 2, L is 4. When we apply the values inside the formula, we are getting 20. In the span CD, there is a point load 12.5 kN. Here we have to calculate 6a x bar right upon L. The formula is WB upon L into L square minus B square. Here W is 12.5, B is 2, L is 5. When we apply the values inside the formula, we are getting 105. Let us apply these two values in this equation and make the second equation. Now let us take the spans CD and DD naught and make the third equation. In the span CD, we have to calculate 6a x bar left upon L. The formula is WA upon L into L square minus A square. Here W is 12.5, A is 3, L is 5. When we apply the values inside the formula, we are getting 120. Let us apply this value in this equation. Finally, we are making the third equation. Finally, we have made three equations. Now, we can use the calculator and find out the final moments. I have used the calculator and got the final moments. We already know MA is equal to 0, MB is equal to minus 1.66 kilonewton meter, MC is equal to minus 3.76 kilonewton meter, MD is equal to minus 10.12 kilonewton meter. So in this analysis, we have calculated all of the moments. Now we are going to calculate the vertical reactions. First, let us take the span AB and calculate the vertical reactions. In the span AB, there is only one moment, MB, which is acting in the clockwise direction. In this span, first I am going to calculate RA. For that, I am going to take moment about B. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. RA is acting towards the point B in the clockwise direction, so it will be positive, and the distance is 5 meter, so 5 RA. Then there are two movements, 25 and 1.66. Both of them are acting in the clockwise direction, so both of them are positive. Finally, for RA, we are getting 5.33. For RA, we got a negative value. That means our assumption is wrong. We assumed that RA is acting upwards, but actually it is acting downwards. Now let us apply the rule summation of vertical forces is equal to 0 and calculate RB1. In this span, there are two vertical forces, RA and RB1. We know that RA is acting downwards, so it should be negative. RB1 is acting upwards, so it should be positive. Here, let us apply the value of RA. In this way, we can calculate RB1, which is equal to 5.33 kilonewton. Now, let us take the span BC and calculate the reactions. In the span BC, there are two movements, MB, which is acting in the anti-clockwise direction, and MC, which is acting in the clockwise direction. In this span, first I am going to calculate RB2. For that, I am going to take moment about C. RB2 is acting towards the point C in the clockwise direction, so it will be positive and the distance is 4 meter. So for RB2, then there are three moments. 1.66 moment is acting in the anti-clockwise direction, so it will be negative. The moments 20 and 3.76 are acting in the clockwise direction, so both of them are positive. Finally, we are getting RB2 5.53 kN. For RB2, we got a negative value. That means our assumption is wrong. We assumed that RB2 is acting upwards, but actually it is acting downwards. Now, using the rule summation of vertical forces is equal to 0, we can calculate RC1. After applying the rule, we are getting RC1, which is equal to 5.53 kN. Now, let us take the span CD and calculate the vertical reactions. In the span CD, there are two movements, MC, which is acting in the anti-clockwise direction, and MD, which is acting in the clockwise direction. By taking moment about D, we can calculate RC2, which is equal to 3.73 kN. By applying this rule, we can calculate RD, which is equal to 8.77 kN. In the point B, we have calculated the reaction two times. Let us add both of them. After adding, we are getting 0.2 kN. For RB, we got a negative value. That means it is acting downwards. For RC also, we have calculated the reaction two times. Let us add the values. After adding, for RC, we are getting 9.26 kN. Now, we are going to draw the shear force diagram. Before drawing the diagram, let us calculate the shear force values. I am going to calculate the shear force values from the point A and towards the point D. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. You can see the shear force calculations. Using the values, we can make the shear force diagram. Now, we are going to draw the free movement diagram. For drawing the free movement diagram, we have to consider every span as a separate simply supported beam and calculate the moments. In this analysis, we have already calculated the ordinates in the beginning. Now, using the end moments, we can make the end moment diagram. Then we have to combine the free movement diagram and end moment diagram. So we will get the bending moment diagram. Now we are going to end this session. Thank you for watching this video.